Rational exponents. So what we're looking at here is a base with a fraction as an exponent. That's what they mean by rational exponents. In the last video, we talked about this in a little bit, but I'm going to just go into detail what this can be transferred to. So remember that we talked about that a negative exponent is really a rule. If we had a negative, we would flip the base. Well, this divisor line is also a rule. And we're going to look at how this can be transformed. This means in here that the base is a real number and m and n are integers. Okay, sorry, m is an integer and n is a natural number. When we have this case, what happens is the n becomes an index number, a number located inside the root part. So it would be the nth root of b to the power of m. So the m remains an exponent. This divisor line turns into a root sign, if you want to say, and the n becomes inside the index. And what we have here is a rational exponent can be converted to a radical, a radical expression. All right, and here it is. Another way to write this is by writing it as the nth root of b first, and then you take that and raise it to the power of m. Whether you do it this way or this way, you will have the same answer. Now, note, if n is even, okay, so if the index n is an even number, okay, so 2, 4, 6, 8, the b, the number under the root sign, has to be a number bigger than 0, meaning it has to be a positive number. Because if you remember, we cannot take the square root of a negative number. So basically the index is here, let's say the fourth root, you can't have a negative 16. Whereas you can do the fourth root of 16, which is 2, but you definitely cannot do the fourth root of negative 16 because there is no number multiplied by itself 4 times that will give you negative 16. It's impossible. So folks, this is correct and this is not correct. An error will show up on your calculator. Now, 125 to the power of 2/3 can be converted to radical form by taking the third root, so the index is 3, and there's a root sign of 125 to the power of 2. Another way to write this is the cube root of 125 to the power of 2, and the cube root of 125 is 5, to the power of 2 is 25. If you type this in your calculator, you also get 25. So whether you write it this way and go this way, or you write it the other way that we had and get to the answer, or go straight here, it depends on what the question asks. This is known as radical form. These are known as the evaluate to the final answer. Okay, let's look at an example. Evaluate the following. Negative. Okay, so let's look at all these answers. These questions. And example number 2, write as a single power, then evaluate. Okay, so what are we actually doing here? Well, in the first part, we just have to get the answer. So you can actually type that in your calculator. If you're asked to write as radical form, you would rewrite it in radical form, but in this case, it's just asking you to type it in your calculator and give me negative, and the answer will give you negative 11. Type this into your calculator, and you will get 5, so 125 to the power of 1/3, and you type that in your calculator, you get 5/7. The next one, this half right here, this negative is saying flip the base. This 2 on the bottom means square root. So we're going to square root negative 1 over 1024. Can you take the square root of a negative? Hopefully you're thinking, no, we can't, and therefore it is not possible. So part C doesn't actually have an answer. It's not possible. Let's look at example 2. Write as a single power, then evaluate. So what that means is we're writing 27 to the power of 1. Why is it to the 1? 1/3 plus 2/3 is 1. 27 to the power 1 is just 27. And you go straight to the answer, no problem. You do not have to write this one here, folks. Now for this one, we have different bases, excuse me, different bases, and we can't do any of the laws for exponents until we actually convert these to the same base. So 2 will be 2. 4 will now become 2 to the power of 2. And you raise that to the half, because that was the original half that was there. And then we're going to divide by 2 to the power of 3, all raised to the power of 2/3. 2 to the power of 3 is 8. Once we do that, we can now get the exponents. So 2 times a half is 1, no problem. 3 times 2/3 is 2. What you're going to do is 1 plus 1 minus 2 gives you 2 to the power of, that's right, 0. What is anything, any number other than 0 raised to the power of 0? That's right, the answer is 1. So anything to the power of 0 is 1. Moving forwards, example 3. Simplify, express your answer using only positive exponents. All right, so here are some examples, and we need positive exponents only. So the first one, we just add the exponents, we get x to the power of 2/3. In the next one, only the x's can go together and the y's go together. They do not go together across this way because the bases are different. Only same bases can use exponent laws. So first one and the second one. So the orange one we're going to do first. What we do is we will get, when we subtract the exponents, x to the negative 2/3. Okay, so we're going to go through this just slowly a second, one more time. So we're going to get x to the negative 2/3. That is from getting 2/3 minus 4/3 will give us negative 2/3. The second part you get is y to the 3/5. That's 4/5 minus 1/5 is 3/5. So you get y to the 3/5 over x to the 2/3. Why? Because this is a negative, and that means you flip the base, and when you flip the base, that means the x will now go to the bottom, underneath. You could also go straight from the question to the answer by realizing that there are more on the bottom than there is on the top. So we're going to take 2 away from the bottom to cancel this out, and we're left with 2/3 on the bottom. And here we have more on the top than we do on the bottom. So when we subtract them, we'll get 3/5 at the top. Okay, moving forwards. Let's go through some of those laws again. Remember that this is the product law. That means when you have 2 powers being multiplied, you add the exponents. 2 powers being divided, you subtract the exponents. A power to a power means you multiply the exponents, and the base and the exponent together cannot equal 0. So that's important. And if you have it to the power of 0, the answer is 1. That is, again, provided that the base is not 0. And this one, m to the power of negative n, means 1 over m to the power of n. So the negative exponent flips the base. And finally, the rational exponent that we just did today means you convert it to radical form. The denominator of the exponent becomes the index, and the top part becomes the exponent on the base. And then we have power of a product law, and power of a product means that each part of the product gets the value. And then we have power of a quotient, and power of a quotient means each part of the quotient gets the exponent. That's all that means, folks. So these are all the different laws you've learned since grade 9. Alright, and that's the end of the video, folks. Hopefully you can do your homework and have a numerical day. Take care.